Hi guys, today we're going to be doing about endothermic and exothermic reactions. So by the end of the lesson we should be able to describe the characteristics of endothermic and exothermic changes, classify changes as exothermic or endothermic, and calculate temperature change and conclude whether the reactions are endothermic or exothermic. First things first though, we've got a starter here on the screen in front of you. So we've got 4 statements and I want you to tell me which ones are true and which ones are false. And with the false ones, I'd like you to write out the correct versions. So pause the video here, give yourself about 5 minutes to do that. Okay, so the answers. There's only one correct one on there, and that's the first one. Thermal decomposition is when the substance breaks down when heated. The others are all incorrect. So let's start with this one on the bottom left. All chemical reactions give out heat. Now this is not true. Some reactions actually take in heat. If temperature of a substance increases, that means it's getting colder. Now we all know that's incorrect. So if a temperature increases, it means it gets hotter. The higher the temperature is, the hotter something is. So combustion reactions take in heat and give out oxygen. That's actually the wrong way round. We know combustion reactions require oxygen and they will give out heat. Okay, so get your homework out from last week and a green pen. We're going to go through the answers. So, question 1. 2 pupils heated some copper carbonate in a crucible. They recorded the mass of the crucible and contents before and after heating. The word equations as follows. Copper carbonate goes to copper oxide and carbon dioxide. What is the mass of carbon dioxide given off in this reaction? So this is a bit of revision from the conservation of mass that you will have done a few topics ago. So what we're going to have to do is we're looking at the mass of the crucible and copper carbonate. This is 51.24 grams. We're going to take away the mass of the crucible and copper oxide, which is 50.80, and the remaining mass is the mass of carbon dioxide that was given off from this reaction, because we know that copper carbonate decomposes to copper oxide and the carbon dioxide is given off. So the difference in mass between these two is the mass of carbon dioxide given off. So what is the name of this type of chemical reaction? Well, it's thermal decomposition. It's this bottom answer here. Okay, next, which of the following reactions are thermal decomposition reactions? So it's the first, the second and the fourth, because all of these show one compound being heated up to form more than one compound at the end. So Jerry thinks that combustion reactions and thermal decomposition reactions are the same thing. Is Jerry correct? Explain your answer. So 1 mark for saying Jerry is incorrect. So you get 1 mark for saying they both require heat, but your last mark for saying combustion is different because it requires oxygen. Okay, some reactions give out heat and some reactions need to have heat provided. So I want you to think of examples of reactions that take in heat and give out heat in everyday life. When do we have to put heat into something to see a chemical change? Think about the kitchen for that one. And when do we get heat out of a chemical reaction? If we think a couple of lessons ago, we had a really good example of that. So give yourself about 5 minutes, see how many you can come up with each of those. Pause the video here. Okay, which one of those was harder for you to think of examples for? I know I personally found it a lot harder to think of examples that take in heat. But here's a few that I've got. So give out heat, we had combustion. We also have condensation. When a gas turns to a liquid, it will give out the extra heat energy. and when cement dries, that gives out heat as well. Now take in heat, cooking is the main example that I've got here. So if you heat up an egg, it will undergo a chemical reaction and it will cook. It's the same with a cake. Yeah? And ice melting, this is an example where I put in heat and a reaction happens. In this case it's a physical change rather than a chemical change. Okay, we have very specific names for these reactions. So, thinking back to last lesson, we've seen this part of a word, therm, before. So, have a think. Can you remember what that means? Well, what that means is it's to do with temperature. Yeah, so we saw thermal decomposition, where it breaks down due to heat. There's also thermometer, the thing we use to measure temperature, and thermal decomposition. So the only thing that we've got to learn about now is what exo and endo mean. Well, exo means out. Like an exoskeleton, an ant has an exoskeleton, which means its skeleton's on the outside. And endo is the opposite, it means in. So in an exothermic reaction, it gives out heat to its surroundings, to everything around it. Whereas endothermic reactions take heat in from the surroundings. So exothermic reactions heat things up and endothermic reactions cool things down. Now a good way to remember this is exothermic, the heat is exiting, so it's giving out heat. Exo sounds like exiting, yeah? Whereas endothermic, it's entering, so it's taking in the heat from the surroundings. It's making everything around it colder. Okay, so exothermic. As we've already said, it's a reaction that gives out energy to the surroundings. So the products will be hotter than the reactants. We'll finish off with everything around the reaction being hotter because the energy from the reaction has been given out to the things around it. So some examples that you might have seen, these hand warmers. So where you click a little button inside them and they start to heat up. That's because the chemical reaction inside them gives out heat. Yeah, so your hands will be warmer after the reaction has happened because that reaction has given out heat. And also self-heating soup. Okay, now looking at endothermic, this is the opposite. So if a reaction takes in energy from the surroundings, then it is endothermic. So our products will be lower in temperature because all the heat has been taken out of the surroundings and has been put into that reaction. So some reactions are thermal decomposition that we looked at last lesson, and also sports injury packs. So where you squeeze it and a chemical reaction takes place inside that makes the surroundings a lot colder, makes everything around it colder. Now I keep saying the word surroundings. What do I actually mean by that? Well, surroundings is just anything around the chemical reaction. So if we do it in a lab, it's going to be the beaker that the reaction takes place in, the air around it, the table, just anything around the reaction that is not the reaction. Okay, anything at all, the room, just anything around that reaction. Okay, so what I'd like you to do now is have a go at the other tasks on your sheet, so task 2 and task 3, and also have a go at the mini whiteboard quiz on the rest of this PowerPoint, and then watch the video at the end of this PowerPoint and try and answer the questions on it. Fantastic, done a great job guys.